actions of traditional agriculture produce as many greenhouse gas emissions as all of transportation globally. Both these actions affect climate change and will be impacted. More extreme weather events, droughts, storms. If we don't change the way that we grow food at the moment, we will face challenges in feeding the population while doing untold damage to our world. This is not the future I want. I'm Alex Montanari, and I'm the founder of Perth-based AGRA Farming Technologies, where our goal is to help bring about a more sustainable agricultural future by developing plant factories that can sustainably produce crops at the same price as traditional methods. Staple crops such as wheat, rice and soy. These are the crops of the greatest impact on our world, and they are the crops that need to be addressed in order for us to have a sustainable agricultural future. AGRA's plant factories grow without sun or soil, utilising artificial lighting and a nutrient-rich mist powered by renewable energy. They take crops out of the field and stack them vertically indoors, growing in a controlled environment managed by software and machines. At the end of 2023, we achieved price parity with the field for leafy greens and herbs, with over 12 months of ongoing deliveries to Perth-based fresh revision supermarkets. Our current agriculture system is vulnerable and has a tremendous impact on our world. We have technology, we have science. This doesn't have to be the case. We can change it.
Towards a sustainable agricultural future. It's 2025, and despite all of our technological advancements, we are still growing crops in much the same way we did 10,000 years ago. We till the soil, we plant seeds, and we hope for the right conditions, with the challenges that we face being inherent to the field. Currently, we have 1,000 proposed solutions to 1,000 different problems, but what we really need is a better system. At AGRA, we have developed a crop production method that can not only solve these problems, but can compete on price with traditional farming. Over the next decade, we intend to apply this to staple crops like wheat, rice, and soy, the backbone of our food supply. This isn't in opposition to farmers, rather we hope this will allow them to do their jobs better while addressing the challenges they face. Let me give you some context. While I was at university, I'd heard all my life that climate change was one of the biggest challenges facing humanity, and that it would be up to my generation to solve it. So I set out to truly understand it. While I saw a clear path to a renewable energy future, with solar rapidly becoming the cheapest form of energy, I learned that agriculture had a tremendous impact on our world, far beyond just greenhouse gas emissions, with no clear path to a global solution. I thought, this is crazy, it's food. If we can't solve this, we're screwed. Plant factories have what it takes to solve these problems, but they are historically expensive to both build and operate. But this doesn't have to be the case. Initially, I looked to existing controlled environment agriculture and vertical farming companies, but they weren't interested in addressing staple crops or achieving price parity. So I concluded that if no one else would, then maybe I should, and maybe this was an area in which I could make a difference. When I started the company 5 years ago, I didn't actually think that I had the capability to design a plant factory capable of competing on price with the field. Nor did I think anyone would give a 20-something business student millions of dollars to try. But looking at the underlying costs, I understood that it could be done. So I started small with a low-cost household device called Hortus to develop the key technologies and generate revenue to fund commercial farms. I taught myself CAD, PCB design, C++, EMC, and design for manufacture, taking the product to market. And this is a production article of Hortus here. However, in taking it to market, I realized that this would actually be a significant deviation from why I started the company. And instead, with the skills, technology, and network that I now had, for the first time, I saw a path to actually producing a plant factory that could compete on price with the field. So I cancelled the manufacturing run, refunded the pre-orders, and started development of Arvum, AGRA's first commercial farm. With limited funding, I looked for a place to build a prototype. Renting space was going to be too expensive, but it just so happened that my girlfriend's parents had this old asbestos shack on their farm, and they were willing to let me use it. I had 2 years until they planned to demolish it. In that shack, I built Arvum Zero, a commercial prototype. I scrapped and rebuilt the structure, brought on a few people to help out, and developed the key technologies, starting with leafy greens and herbs, as they offered the shortest path to market at price parity. Initially, when I started the company, I thought that there were a few key technologies required in order to achieve price parity. But when building the prototype, much to my dismay, I realized that I was wrong. Much like building a cheap car, you can't just put on cheap wheels. You have to design every part and how that part is made in order to be low cost. One example of this is labor, which accounts for about 40% of production costs in existing plant factories. Conventional mediums like soil, rock wool, or perlite, while really easy for humans to use, are really hard for machines because they're designed for humans. And in order to eliminate the labor cost, you need an automated design. So I developed an aluminium-based growing media where the roots penetrate through, hanging in air, where they're then misted with a nutrient solution. I actually remember talking to some of my research colleagues about this at university and them going, aluminium, that makes no sense. Like, how could that even work? But now it does, and it supports all stages of growth, but most importantly, it allows for a cheap and simple automation design. These kinds of changes extend across every part of the farm, resulting in 20% greater yield, 37% lower production cost, and 60% lower construction costs compared to the next best competitor. We've now been delivering to fresh provision supermarkets in Western Australia for over 12 months at price parity with the field. As far as we're aware, no other company has been able to achieve this. In that time, we've consulted for the Defence Force, are a partner in the Australian Plant Phenomics Network, and have a research partnership with the University of Western Australia, publishing 2 research papers and co-supervising a new master's program on the technology. We've received commitments from both Fresh Provisions and Woolworths for our forthcoming pilot, with Woolworths expressing interest in purchasing produce from our first commercial farm. And that leads us to today. We're currently building a pilot to validate the technology at scale. Once proven, we'll build our first commercial farm, and then we'll franchise the technology globally to farmers and entrepreneurs. And this is happening right now. Construction is underway. For the first time, we've been able to achieve price parity for leafy greens and herbs, crops already well optimized for controlled environments. These same methods can be applied to staple crops like rice, wheat, and soy. At scale, the production cost will trend towards the cost of energy inputs. In our pilot, we expect an energy ratio of about 35:1. That meaning for every 1 unit of edible biomass, it requires 35 units of energy. In our first commercial farm, we see this dropping to about 20:1. So let me break this down for you with a real-world example, rice. By 2030, the cost of renewable energy will reach about 2 cents a kilowatt hour, and by 2040, 1 cent a kilowatt hour. The retail price of rice is set to reach about $2 a kilogram by 2030 and $2.50 a kilogram by 2040. With photosynthetic improvements, that energy ratio I mentioned previously could plausibly reach about 10:1. And finally, 1 kilogram of rice contains about 4.3 kilowatt hours of energy. So here's what this could look like. By 2030, this becomes feasible, and by 2040, highly achievable. Sometime in the early 2030s seems like the most likely scenario. Now, I understand this might look a little bit confusing, but essentially, rice at the supermarket today is about $1.80 a kilogram. In future, this price is going to increase, while the cost of production in plant factories is going to decrease. plant factories offer one of our best shots at a sustainable and resilient food supply. And we're seeking partnerships across academia, government, investors, and retailers in order to make this future a reality. It might sound ambitious, but this can be done, tackling crops in a phased approach, starting with leafy greens and herbs, then fruiting crops, and finally staples. It's 2025. If we work hard, we can develop the technologies to solve the challenges that we face, just as we're seeing with renewable energy. Our next 10,000 years depend on it. Thank you.